Welcome to Your Math Explained, where we make math simple and clear. My name's Angela. Imagine you're building a staircase out of wooden blocks. The first step takes 3 blocks, the second step takes 5 blocks, and the third step takes 7, and so on. If you want to build a massive staircase with 100 steps, do you really want to just sit there adding 2 over and over again until you reach the top? Of course not. This predictable stepping stone pattern is what mathematicians call an arithmetic sequence. Today, we're going to crack the code behind these linear patterns so that you can predict the value of any step in an infinite chain instantly without doing the manual grunt work. Now, before we jump in, if you haven't subscribed to the channel yet, make sure you do that first so you don't miss out on new weekly content. So in order to look at the shortcuts, we need to first define our terms. Now, a sequence is simply an ordered list of numbers. And the word arithmetic just means that the transition from one number to the next always uses a basic addition or subtraction. And this fixed amount that we add each time is called the common difference. So here you can see that the formula is already written on the screen. Now u sub n stands for the nth term in the sequence. So that means u sub 1 is the first term. N here is the position of the term. So is it the first, the second, the third, and so on. And then the d here is our common difference. So now one thing that a lot of students get tripped up on is the difference between u sub n and just n. So n is the position of the term, and u sub n is the actual value of that particular term. So IB will use u, whereas most textbooks will either use a or t. And they all mean the same thing. So let's take a look at how this formula is built. So if u sub 1 is our first term, then that means u sub 2 is going to be the second term, and then u sub 3 will be the third term, and u sub 4 will be the fourth term, and so on. But because this is an arithmetic sequence, we know that to go from one term to the next, all we do is we add the common difference d, which means in order to get to u2, this is u1 plus the common difference d. And similarly, to get to u3, this is going to be u2 plus d. But we know that u sub 2 is equal to the first term plus the common difference d, which means this now can be rewritten as u sub 1 plus 2 times the common difference d. And then similarly, the fourth term is going to be u sub 3 plus d, which is the same as u sub 1 plus 3 times the common difference d. So notice the pattern here. We start with our first term, which is u sub 1. This is our beginning. And for any particular term, that is going to be equal to the first term plus 1 less than your current position multiplied by the common difference d. And that is exactly what this formula here is saying. It's saying that if you want the value of the nth term, it's going to be the value of the first term plus the current position of that nth term, which is n, minus 1, and multiply by the common difference. Now let's take a look at how we can use this through an example. For this example, we're asked to find the number of line segments in the 25th diagram. So for the first diagram, we have 1, 2, 3, 4 segments. And for the second diagram, we can think of it as we have our original 1, 2, 3, 4, and then we add 3 more segments. That would be 5, 6, 7. And then for the third diagram, we start with the second diagram, which is right over here. So that would be 7 segments. And then again, we would add 3 more. So that would be 8, 9, 10. So from this, we can go ahead and write down all the information that we're given, which is that the first term, u sub 1, has a value of 4. The common difference here, d, is going to be equal to 3 because we add 3 more segments to create the next diagram. And the term that we're interested in is the 25th one. So which means we know that the position of that term is 25. So n is equal to 25. And finally, what the question is asking for is u sub 25, which is what is the actual value of that 25th term. So now we can go ahead and use our formula. So this is going to be u sub 25 is equal to u sub 1 plus, our n here is 25 minus 1 multiplied by the common difference d. Now substituting in the other values, we get this is 4 plus 24 times 3. Then we get u sub 25 is equal to 76. So therefore, the 25th diagram is going to have 76 line segments. That was pretty straightforward. So let's take a look at the next example. So for this question, we're given that an arithmetic sequence has a t sub 1 of 12, meaning the first term has a value of 12. And we're also given that the 15th term has a value of negative 30. And we're asked to find what the common difference d is. So again, we're going to start by writing down the information that we have, which is t sub 1 is equal to 12, t sub 15 is equal to negative 30, and because we're given the 15th term, we know that n is equal to 15. And what we're trying to find is the common difference d. So same thing, we're going to go ahead and write down the formula, which is going to be t sub 15 is equal to t sub 1 plus n minus 1, so n here is 15, multiplied by the common difference d. And now we just substitute in the values that we're given. So we get negative 30 is equal to 12 plus 14 times d. And now this just becomes an algebraic equation where we solve for d. So we get negative 42 is equal to 14d, which means d is equal to negative 3. And then for our last example, we're asked to find how many terms are in this particular sequence. We're going to start the same way by writing down all the information that we have. We have the first term is equal to negative 5. And then we know that our nth term, which is the last term, is 115. But we don't know what n is. In fact, that's what we're trying to solve, because once we find out what n is, and that is the last term, now we know how many terms there are in total within the sequence. So n is what we're trying to find. But we also know what the common difference is, because we start from negative 5, we go to negative 1, and then 3, and then 7. So here our common difference is positive 4. And now all we have to do is put this into our formula. And the formula here is u sub n is equal to u sub 1 plus n minus 1 times d. So we know what our u sub n is, that is 115. We also know what our first term is, that is negative 5, plus we don't know what n is, so that stays as n minus 1. And we know that our d is 4. And now this is just, again, an algebraic equation where we solve for n. So we get 120 is equal to n minus 1 times 4, which means n minus 1 is equal to 30. So therefore, n is equal to 31. So that means there are, in total, 31 terms in this sequence. And now let's do a quick recap of what we covered in this video. We learned that arithmetic sequences are just lists of numbers that increase or decrease by a constant added value, which we call the common difference d. And we saw in the formula that we multiply this common difference d by n minus 1. And the minus 1 is there because we don't add the common difference the first term. We only start adding it in the second term. So within the sequence formula, there are a total of 4 variables. There's u sub n, u sub 1, n, and d. As long as an exam question gives you any 3 of those 4, you can isolate the missing one and solve for it. And now it is your turn to give this a try. Can you find the solution to the problem on the screen here? Make sure to leave your answer in the comments below and let us know what other sequences and series topics you'd like to see in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.